right hand side. So you didn't have to do the thing that I did initially with the whole, but I just want to show you that because that's how you initially kind of like, you know, prove it. And now once you have your identities, now that once an identity has been proven, you can use it now to prove other identities, right? It's kind of like a building block. And I think that it is it. I guess we can do one more. No, it's fine. We're just going to move on. Here we're going to move on to this. Okay, here we have all the compound angle formulas. We have sine brackets x plus y equals sine x cos x plus cos x sine y, and so on. You need to memorize this. You need to get a formula sheet. You need to memorize these. You need to write these down because you are going to use these throughout this unit. And let's do our first example in which we use these. Okay. Oh. Give it a moment. Should show up. Or not. There it is. Okay, example 3. Determine exact trig ratios for angles other than special angles. So now we are going to be looking for exact values other than, you know, your angles being 30, 45, and 60. So 30, 45, and 60 are very easy. You have your special triangles. They've been proven. You know what sine of 30 is. You know sine of 60 is. You know what sine of 45. And, you know, cos of 30, 60, and 45, and so on. Pretty straightforward. Or, you know, since we're using radians now, pi over 4 and pi over 3, pi over 6. You should have these special triangles memorized. But now we're going to use our knowledge of compound angle formulas to find exact values for angles other than these 3 special triangles or special angles. Here we have an angle of sine pi over 12. I recommend if you struggle with figuring out, like, you know, conceptualizing and like imagining what angle pi over 12 is, just convert it into degrees. You can just easily convert it and just convert it back into radians once you feel like it. So first things first, pi over 12, if you don't remember to convert that into degrees, we multiply by 180 over pi. Essentially just doing 180 divided by 12. And what is that equal to? Let's see, probably 15 if I had to guess. Let's see, 180 divided by 12. It is 15. All right. So this is the same thing as sine 15 degrees. And we're trying to look for exact values. So you can't just plug this into your calculator. You most likely will get an approximation in your calculator, like a decimal value. So we need exact values. The way to do this is to realize, well, what are our special angles again? So they're 30, 45, 60. Is there a way in which I can add or subtract any of these special triangles such that I can make 15 degrees? There's actually more than one way you can do this. You can do 60 minus 45, right? Or you can do 45 minus 30. Both will give you an angle of 15 degrees. The reason why I'm doing this is because with compound angle formulas, we can rewrite sine of 15 degrees as sine of bracket 60 minus 45. Now here you could change it back into radians if you want. Doesn't really matter. It depends on what you're doing. I guess I should change it to radians because grade 12 we're doing radians. So that's the same thing as sine of pi over 3 minus pi over 4. If you don't believe me, just, you know, just do it. 180 divided by 60. Or sorry, 60 divided by 180 and then 45 divided by 180. And then you'll get the fraction. Okay. This is a situation for our formulas that we just figured out, compound angle formulas. This is an example of sine x minus y. So I'm going to go back and I'm going to look for sine x minus y. Sine x minus y is this one here. And that is equal to sine x cos y minus cos x sine y. I remember when I was in university, I had to memorize all of these. So if you're planning on taking any calculus in university, you will most likely have to memorize these trig identities. So remember, sine x, y, sine x cos y. Oh, sorry, my S's are a little off. Cos y, so cos to the power of 4, minus cos x sine y. And now we've written an example, an equation that solely deals with our special angles. And these are our special triangles at the top here. So power 4 and power 3, power 6. And we can just use the special triangles and write this as ratios now. So sine of power 3. What is sine of power 3? Power 3 is here. It's 60 degrees in case you're wondering. It's opposite, which is root 3 over 2. So root 3 over 2. That's our first ratio, root 3 over 2. Remember, these are all multiplying. Cos of power 4, that's just 1 over root 2. Cos of 45, same thing. 1 over root 2. Easy stuff. Then we have a minus sign. Then we have cos of power 3, which is probably a half. Yep, 1 over 2. Multiplying. And sine of power 4 over 45 degrees is 1 over root 2. And that's it. Now it's simple. Now it's just a basic, fraction, radical, adding, subtracting question. There's no trig involved now. So we're just going to multiply root 3 by 1 and 2 root 2. And we're just going to multiply this over 2 root 2. And you know what? The denominators are exactly the same. So we can just combine this and leave the answer as that. There you have it. That's the final answer. This is the exact expression for sine pi over 12. And one way you can test this out is by plugging this into your calculator. If you get a calculator, and let's see here, we have root 3, so root 3, do that in your calculator, 1.73205 and so on, minus 1, you get 73205, then you divide it by 2, then you divide by root 2, and you get 0.2588, approximately. Obviously, I'm rounding to the 4 decimal places. And we can now do sine pi over 12 in your calculator. Now, what's important is you have to have your calculator in radians, not degrees. If you have it in degrees, switch it over. Otherwise, you will make a mistake. So pi over 12, that's pi divided by 12, and sine of that answer. And if you do it correctly, you will also get the same value, 0.2588. And you know that you did it right because this and the initial value are exactly the same. So yeah, that's the good thing with trig is you can always check your work, see if you did it right or wrong. Let's go on to the next example now. Sorry, 1 second. Wait, there it is. All right, next example is this one here. We have tan of negative 5 pi over 12. Whenever you're dealing with a negative angle, simple solution, don't. There are ways to get rid of that negative sign. So for odd functions, you can just take the negative and put it in front. So that's what that equals. For even functions, it's just equal to its positive, angle. So you can just get rid of it like that. So in this case, tan is an odd function. Just take the negative out. We have negative tan 5 pi over 12. Now what? Well, what is 5 pi over 12? Like, what angle is that? How do we use that? We need our special triangles. Let me get our special triangles. Let me just see if I can copy this. Oh, wait, I just realized I can copy it from here. Sorry, one moment. There you go. All right, we have our special triangles here. You can keep everything in radians. If you're good with adding and subtracting fractions, you can just be like, oh, pi over 3 minus pi over 4 is 5 pi over 12 or something along those lines. If you're not amazing with that, just convert it into degrees. 5 pi over 12 times 180 over pi. Pi's will cancel out. That's probably 75, if I had to guess. Because, yeah, it makes sense to me. Let me just confirm. I don't want to make a mistake, you know? Yeah, it's 75. Okay, so that's 75 degrees. And remember, looking back at our special angles, is there any way for me to make 75 degrees by adding or subtracting these values? And you can add 30 and 45. So what we're going to do is we're going to rearrange this and write tan of 30 plus 45. And I would, you know, change it back to radians now since we are dealing with radians. So 30 degrees is the same thing as pi over, what, 6, I believe. And that's pi over, oh, I'm blanking out now. Is it 4? Sounds about right. No, is that right? Yeah, that's right. That's right. Okay. So yeah, so we've now changed it into terms of this. Now, what is our compound angle formula for tan? So let's go back and, oh, you know, I'm so silly. I can just copy it from here. So here we go. All right, here we go. So this is an example of tan x plus y. X being pi over 6, y being pi over 4. So this is the same thing as negative. Remember that negative sign? It's always there. Just leave it out. Just leave it at the very front. Don't even incorporate it in yet. All right, we have tan x. So tan of pi over 6 plus tan of pi over 4 all over 1 minus tan of pi over 6 times tan of pi over 4. And what is tan of pi over 6? Well, let's look at our special triangles. Tan is opposite over adjacent. Oops, let me move this a little down so you can see that one. So tan of pi over 6, 1 over root 3. So this is going to be 1 over root 3. One over root 3 plus tan of pi over 4, which is opposite over adjacent, so 1 over 1. So 1 over 1. And this is obviously 1 minus tan of pi over 6. We just did it as 1 over root 3, remember? Times, obviously, 1. Okay. So now I've successfully substituted all the ratios into our fraction. But there's a lot of, you know, crazy stuff going on. There's your numerator, there's your denominator, there's fractions in both. It's kind of confusing. So we're going to simplify this. We're going to make it very easy. We are going to deal with the numerator first. I'm going to combine that into one fraction. So what I'm going to do is save myself some writing. And 1 over 1 is the same thing as root 3 over root 3. Common denominator, right? So that is equal to, remember that negative sign? Still there in the front. So that's equal to 1 plus root 3 over root 3. So the numerator has been simplified into one fraction. We're going to do the exact same thing with our denominator. So remember, our 1 here is root 3 over root 3. Common denominator. So that's going to be root 3 minus 1 over root 3. So now we have a fraction in the, these are brackets, by the way, that are not really extending all the way. There you go. Okay. And if you're confused on how to do this, just do it the long way, which is rewrite both fractions. Because I know this is confusing for some people. When you're dividing fractions, you flip the second fraction, change the sign to multiplication.